welcome to this talk. My name is Sunil Agarwal, and I lead the program manager team for Postgres. And behind me, you see a fish. Bash fish is a symbol of our team. The Postgres team within Microsoft is called Orcus. So that is that fish sitting behind me. And in this session, we will go over top 10 reasons why you should choose flexible server over our existing offering, which we call single server. The agenda for this talk is rather simple. I will go over architectural view of the flexible server, and then we will go over 10 value propositions, and then we will summarize. So what you see here at a very high level, how flexible server looks like in Azure. So here what you see is we are hosting flexible server on a Linux VM. The first thing is why it is so important, because Postgres engine was architected on Linux. So in some ways, Postgres and Linux are natural habitat together. So by hosting flexible server on Linux, we have simplified our architecture in a very significant way. Okay. And then you see that flexible server is connected to the premium storage. This is the premium SSDs. And this is where we store the data and the transaction log. Okay. Now, one thing which is interesting is if for some reason this VM dies, okay, it can happen, machine dies, flexible server will automatically create a new VM and host this Postgres flexible server on the new VM. So from that perspective, you have a node resiliency in terms of availability. Similarly, if you notice, we have 3 copies of the data. So if any copy gets corrupted, you are safe from that perspective also. So one thing to note is the flexible server in its current configuration without HA is resilient from node failure. It is resilient from storage failure. Okay. Now the third thing that you will see at the bottom is the zone redundant or zone resilient backup storage. This is where we put the database backups periodically, and we do a transaction log backup every 5 minutes. This is where we upload those things. Now, why this is so important? Because imagine if your availability zone 1 becomes unavailable, there is something happens. Your backup is resilient to that failure. Your backup is still available for zone 2 and zone 3. So you will be able to do a point-in-time restore of your flexible server in availability zone 2 or 3 using this backup. So at some level, you have a zone resiliency available to you for your database, but it involves point-in-time restore. Just keep that in mind. The other thing which you see on the left side, this is where your client is sitting. You can put your client application in Azure VM, or you can put your client in Kubernetes, or you can run app service. So whatever the client is, you can choose to host the client in the same availability zone as your Postgres flexible server. Now, the benefit of this one is that the latency between your app tier and your database tier is much, much lower and is very predictable. Within an availability zone, the latency is less than a millisecond round trip latency. So if you have an application that is very chatty and you need low latency connection, flexible server can be configured in that mode. So with that, I want to summarize 3 key points that we have just discussed. One is flexible server architected on Linux, simplified architecture, fewer moving parts. Number 2, the lower latency. I'm referring to the co-location of your client and the flexible server in the same availability zone. The latency, as I said, was under 1 millisecond. And the third thing is it is AZ resilient, the availability zone resilient, and database backup, as well as transaction log backup. So you can do a point-in-time restore to another availability zone. So those are the 3 benefits. Let's move on to the next one. So the next one, which is what I want to show you, I have architected flexible server with a high availability. Now with this high availability, what you get a standby, which is standby that I'm showing you in availability zone 2. This is exactly what you have in primary, which is on availability zone 1, but there's a standby, which is running, which is replicating the transactions that you're running on the primary in synchronous mode. So you see here, all the changes that are happening to this database, they are coming in a synchronous way to the standby. When I say synchronous way, it means that when a transaction is committed, primary will make sure the transaction is persisted in the storage here, acknowledged. Only then we will acknowledge to the application that the transaction has committed, right? So in that case, there is no data loss. So if for some reason availability zone 1 goes down, or this primary server becomes unavailable, we will transparently fail over to the standby, which will now become your new primary, and your workload will run as if nothing changed because there will be no data loss. Okay. Now this is a very useful configuration if you are looking for a mission critical workload which can tolerate very little downtime. So the fourth value proposition of flexible server is that it offers zone redundant or zone resilient HA, and it detects the failure of the primary, and it does auto failover with the same connection string. And because the standby is applying the transaction logs as they are coming in, when the failover happens, the time taken for recovery is much lower in a typical case. So you will expect a much lower RTO, and with the HA option. The fifth item that I want to talk about is performance. So one of the goals of flexible server was to provide a very comparable performance to what a customer can get on a VM. Okay, and with flexible server, we were able to achieve that by tuning the flexible server parameters in such a way that we get very comparable performance. And as well as because we were able to co-host in co-location way and simplified architecture, all those things combined gave us a very comparable performance. And to show those numbers, what we did was we ran a test with PgBench. PgBench is a very standard benchmark tool for Postgres applications. So notice here, I have a server which I'm running on a VM, right? Infrastructure as a service. And I chose a burstable compute B1MS, which is our lowest SKU, 32 gigabyte of storage and 2 gigabyte of physical memory. And the database size was 3 gigabyte. And notice with the VM, I'm getting 811 transactions per second. Flexible server with the same configuration is getting 770. So if you notice, it is within 4 to 5% of what performance I could get on a VM. And similarly, if you see the general purpose SKU here, D2 SKU, which is 2 vCore, 8 gigabyte of physical memory, and the database size 13 gigabyte. The reason we chose a much higher database size here rather than 3 gigabyte, because we wanted to make sure we have a database size that is much larger than your physical memory. And notice here again, the IS is giving me 1042 transactions per second, and while flexible server is giving 997, roughly 4% below. So this is what you would expect, maybe 3 to 4% of tax. Otherwise, performance is very comparable. Now, there's another trick we did. We uh, introduced a compute as part of flexible server offering, which is T2S DV4 that you see here. And what this compute offers, a VM with this compute offers, is it has a local storage, local SSD. Okay, so remember, flexible server was storing data into the premium SSD. And apart from that storage, with the D2 DBS V4, we have a local storage. Now, what it means is, like here, you see that D2 DSV4 has 75 gigabyte of local storage. Here we have 50 gigabyte of storage. Now we use this storage as an extension of your shared buffer. So this is an extension of your shared buffer, means that if you have a page, a data page in your shared buffer memory or flexible server, and if that page has to be kicked out of the cache because of the buffer pool policy, instead of throwing that page out, we will persist that page onto the local SSD. Now, if that page is needed again, say you want to run a query few minutes after that, so instead of fetching that page from the premium SSD, we will be able to get the page directly from the local store. So you will pay much lower latency to get the page into your shared buffer. So you will get a much faster IO performance. And with that, we have seen up to 40% performance boost. Of course, those performance boosts will be for read heavy workload, because those are the pages that we store, the pages that are not dirtied in that local SSD. So those are the key benefits, like the performance. Now let me switch gear and let me take you to the portal to talk about the other 5 improvements or things that we have done, which will be of interest to you. So I'll go to here first, show you the provisioning experience that we have. So here what you see is when you come to the Postgres provisioning page, you will see that you have a flexible server option and a single server option. So single server is our older server, which we released 4 years ago. And flexible server, as I said, is our new offering. So if I'm going to go create here, right, I'm going to go create, and I'm going to show you a couple of things here. So I'm going to create here, and you will see a very similar screen that you had in single server. Okay, when I come to create, the first thing that you will see is that I can choose which availability zone I want to deploy in, right? I can choose 1, 2, or 3. This is the availability zone. And I will choose the availability zone, the same availability zone where my client application is sitting, right? If it is in availability zone 2, I will choose availability zone 2 to co-locate the two. Second thing is, when I'm provisioning my flexible server, like typically people come, I want to first provision it for my development environment, or for my, I have a very small production database, or I have a very large size in the sense mission critical. So question people struggle, which one, what configuration should I choose? So what we do is we provide you a very simple buttons, and we come up with, say, hey, if you want to go development, we recommend you to try B1MS. So when you choose B1MS, that becomes your development SKU. You can change it. I'm going to show you can change it, but this is our recommendation. Now, if you want to have a small thing, we will say go to general purpose. If you have a large thing where you have workload requirement of more memory, we can say, okay, why don't you go to the memory optimize, right? And you can go from 2-week or to 64-week or depending on your needs, right? So that we have simplified that experience quite a bit. And then you can also choose like high availability or not high availability. Remember, like you can provision your flexible server with HA and without HA. Okay. So let me now go to the configuration part. So when I go to the configuration part here, notice I chose memory optimized because I chose production large. And notice here, I'm seeing different kinds of SKUs. So I'm seeing like V3 SKU and V4 SKU. And V4 SKU, as I was showing you earlier, gives you the local disk, which can extend your shared buffer, and this can help significantly in your workload performance. And there is no cost difference, so we would say you should prefer using that SKU. Okay, so I'm going to come back and I'm going to skip these changes, and I go back to the create screen. Now, the other thing that I want to show you, if I have a service that I have already created. So what I go to a different screen, where notice I have a Sunil A server, which is non-HA. So this is not enabled for HA. So one thing that you will see is I can stop it. Okay, when I stop it, and it will stop the server. Now, why would I care to stop the server? Now think about this, right? Suppose you're using your flexible server for development. So your developer comes, say, 8 in the morning, and they work till, say, 6. And after they are done with that, they want to sign off, and they will come back next day to do the development. So what happens between 6 p.m. and next morning, 8 a.m.? If your server is running, you're paying both for the compute and for the storage. All right. Now, by stopping the servers, you have removed the compute from the servers. We maintain the database, so the data still stays. It's just that we remove the compute. So once the compute is gone, You're not paying only the cost for the storage. And next morning when you come, you will start the server. You will start the server, and then the compute will be created, attached to your database, and you're up and running. And so that, I think, is a very useful thing from a sort of a saving the cost perspective. Other thing that we have heard from customers, right? I uh, want to control when maintenance is done on my service. Remember, in a managed service, we do periodic updates, right? We will keep doing enhancements. So every month or so, we will deploy new bits. And in single server, there was a very little control. We will give you a 5-day notice or 3-day notice, and you will have a 15-hour window where we can do the maintenance, even though the maintenance actually will take 2 to 3 minutes, but the window is large and customers were not happy. They wanted to have more control on it. So what we did for flexible server is you click on maintenance, and what you see here is that you can have system manage schedule. This is something we will choose. Remember, here start time is 11 and end time is 7, 8 hours of window. Or you can say custom window. When I do custom window, I can say I want to do my maintenance on say Saturday, because that is the best time for me, and I want to do UTC like 21 to 22. And when I save it, essentially what I'm saying is whenever we do the maintenance, number one, it has to be done on Saturday, and it has to be done between this is 9 to 10 p.m. Right? That's what we are saying. Now, with that, as an enterprise customer, you have full control on the maintenance time. Very, very important. Other thing that I want to show you is server parameters. So if I click on server parameters, so I'm going to skip that and come to server parameters. So we have added many, many new server parameters. And why did we add those? Because we found that there were many customers who had a deeper expertise in fine-tuning these server parameters to get the maximum performance out of their workload. And so, for example, if I show you here, if I go to buffer, right? If I go to buffer, now you can configure shared buffers. Like here's a default value, but I can change it. So now you have a way to change, because if your workload does not have too many connections, you don't have any other memory overhead, but you want to have a larger buffer pool, you could do that, right? Or if I go and I do uh, something to do with my wall, let me search here, right? You can do checkpoint timeout, which was not available before. You can do wall compression. You can do many such parameters that were not available before. So what I'm trying to show to you is that we have added a lot more richness to the server parameters. And one more last thing that I will show you about these parameters is the connections, right? So previously, if you remember, in single server, number of max connections was very closely tied to the number of CPUs you have. Now with flexible server, we give you an option to choose the max connections. Now, this number that you see, 859, for MySQL, this is the limit that we recommend out of the box, but you can change it. You can change it anywhere from 25 to 5,000, right? And you need to be make sure that if you choose higher number of connections, it would take a lot more memory from flexible server, because we have to have that many connections memory reserved. And so you'll have a smaller memory for something else, but this is something you can tune based on your workload. All right, so we have much richer set of parameters. Other thing that I want to show you is the connection pooling, which is also very important, right? So if I go to PgBouncer, I'm going to search here, Bouncer. You notice with flexible server, you get inbuilt managed PgBouncer. By default, it is off, but I can choose to enable PgBouncer. Now, what it means is, now if my application is running with very short running connections, that can be very taxing to the flexible server, because if you have connection that uh, you have a simple query runs, creates a connection, runs the query, goes out, there are a lot of resources, CPU spent in creating the connection, right? Now, if you have a connection pooling, then there are fixed number of connections created pre-created, and your short-running connection queries can just leverage those things. Now, before single server, if you had a workload like that, and we had many workloads like that, we had recommended customers to create a PgBouncer pool uh, between application and the single server. Now, with the flexible server, you can have an inbuilt PgBouncer. So all you have to do is enable it, and then your application, instead of connecting to a port 5432, which is a standard port for Postgres, you will connect to, I think, 6432. We will see a slide on that. So you can do that. All right. Very, very useful. With that, I'm going to switch to my slides, and I'm going to go to uh, the performance thing that we were showing, right? So I'm going to go a little faster on this one. So remember, we were talked about this, that number 6 benefit, I'm going to call it out, that it is much intuitive experience when you're provisioning the server. We provide very similar capabilities. One command provisioning of Postgres flexible server through CLI. We have planned control maintenance. This is number 7 benefit. We have more server parameter control. I was showing you many server parameters like connections, right? And built-in PgBouncer. Right. Now, the last slide on this one, where I want to spend a little bit more time, is the cost optimization, which I did not show you in the portal experience. So one thing that you would notice is with the burstable queue that we have, one of the things with the burstable queue is it accrues the CPU credit. So it starts here, and if you're not using CPU much, like in this case, my workload is not using CPU much, those credits accrue, and then you have a burst of CPU activities. Then you can use those credits to go higher in terms of CPU and exhaust your burst CPU credits, then it can come down. So if your workload required some burst of transactional activity, you do not have to provision for the max burst transaction throughput workload. You can configure the CPU for bursting, right? So this is something you get automatically. Second thing which premium SSD offers us is you have burstable IOPS. So here you get 3,500 IOPS for 30 minutes. What it means is if I've configured my storage, notice I'm going to walk through this example, 32 gigabyte of storage. I get provision IOPS 120, but for 30 minutes, I get 3,500 IOPS, right? So if I have, again, a bursty load where I'm, say, bulk loading data for some time, and after the data has been loaded, my IO activity is much lower. So again, instead of provisioning your storage to handle that IOPS, we automatically give you this bursting IOPS capability. And this accrues. So for example, after you have exhausted your bursting of IOPS, and after that you're using much lower IOPS than your provision IOPS, the difference will keep accumulating, and you can leverage that in future. And we did talk about the start and the stop, where we can stop. So this three things, like bursting of CPU and bursting of storage and the stop and start capabilities, gives you a much lower cost for your workload. And for those who are starting completely new, we also offer a free tier for 1 year. So you can get Postgres Flexible for free for 1 year, and you can do whatever development you want. With that, I will summarize. So the talk of the key goal of this talk was to talk about 10 reasons. I'm just going to iterate through those 10 reasons. One is, first is simplified stack with Linux, AZ colocation to get much lower latency, zone resilient backups. We have zone redundant HA, superior out-of-the-box performance. Remember, we talked about performance that is comparable to VM. It's developer friendly, very simplified provisioning of your um, servers. You can just one command submission and you're ready to go. Customer managed window, and we provide max control of server parameters, shared buffer, max connections that we talked about, built-in connection pooling, and then lower TCO, burstable queues, burstable storage, stop and start. So this is, and we hope that you found these reasons compelling enough to move your workload from single to flexible. Or if you were thinking about Azure and thinking, should I go to single or flexible? We recommend very highly you come to flexible, and some of the reasons are here. And if you have never used Azure before, even then, if you're coming to us, you can see these are the very competitive capabilities that we offer through flexible, and we invite you to try flexible and be successful with us. With that, thank you so much.